All right, so can everybody see the screen? If you can see the screen, say yes in the chat. If you cannot, say no. So if you can see the screen, say yes in the chat. All right, so can everybody see the screen right now? Yes, okay, very good. So today we are going to be reviewing semester 1 material. All right, so our schedule for today, we're going to go over last class's homework questions, and we're going to do all of those review problems. So everything is just going to be practice problems today. So I want a lot of participation, and you can write your answers in the chat. Okay, so let's start with this as our first homework question. All right, so post your answers for the homework in the chat, and let's go over this question. All right, I'll give you a couple moments to post your answers in the chat. All right, so let's solve this one. Who wants to volunteer to solve this one? How about, let's see. Kaylee, would you like to do this?
Okay.
All right, so how would you do this?
That's equal to, well, first you have to simplify it, so that's equal to x squared y to the fourth power, and divided by 5x to the negative third power and y.
All right, this is equal to?
That's equal to x to the power of 5 and y to the power of 3.
Very good. So then when you combine it, it's x to the fifth, y to the third over 5. All right, very good. Now let's move on to our second homework problem. Okay. All right, so let's solve this one. So, who wants to help this time? How about Elaine? Elaine, do you want to help us solve this problem? You can type it in the chat if you want. All right, I'm just going to go over this. So, let's see here. So, it's a radical, and you can just simplify this real quick. So, all that is inside the parentheses is just going to be 4 times x to the 7th, y to the 7th, right? Because you simplify the x's, and then since it's a square root, you can separate these like so. Obviously, the square root of 4 is 2 times the square root of 7 is going to be equal to x to the 3rd and just x, and then multiplied by y to the 3rd times y. You combine it all, it's 2x to the 3rd, y to the 3rd, x, y. All right, so now let's try the last one. All right, and then let's go over this one. Okay, so for this one, this is just going to be equal to another radical. So let's see here. So the cube root. So what you want to do is you want to separate the cube roots out, right? So where can we find a cube root? It's 8 times 4. 8 is a cube root. And then it's n to the 6th times n squared. N to the 6th is a cube root, or a perfect cube. M to the 6th is another perfect cube, and then just times m. So then you take these out, right? You're going to get 2 times n squared, m squared, to the cube root of 4n squared m, right? All right. So, no questions, right? So now we're going to review Unit 1. So I want some participation. Okay, so first, type in the chat, all right? Type in the chat. So you can tell me, so in Unit 1, we learn about, all the operations. and the order of operations. So who can tell me what is the order of operations? Just real quick. It's very easy. So what is the order of operations? Just type in the chat, okay? So type in the chat, what is the order of operations? PEMDAS. Very good, very good. So PEMDAS, the P in PEMDAS is going to be parentheses. And then exponents, multiplication slash division. They're on equal levels, so you just go left to right with multiplication and division, and addition slash subtraction. So it's going to be parentheses, exponents, multiplication slash division. And this one, you just go left to right, whichever is leftmost you start with. And then addition and subtraction, again, left and right. All right, so what about substitution? Who can explain this problem? So when you evaluate something, this expression, if y is equal to -2, for example, what are you supposed to do? What is this asking you to do? So who can explain this problem? All right, what does it mean? All right, so yes, to replace 2 with -2, and we call this substitution. All right, so this is called substitution. We've learned this very easy. So all you need to do is you need to plug y in for -2. So let's just do that real quick. I'll give you like a few moments to do this. All right. Okay. So just do this problem and we'll go over it. And that's basically all we did in unit 1. Is pretty easy. Didn't do many hard stuff. So just do this problem real quick. You can use your calculators. It's all fine. It's just evaluation. Should be pretty quick work. All right. So -73. Very good. Very good, Isabella. So let's see here. -73 looks about correct. So this is 4 times -2. See, just sub in -2 for y. So it's all very simple. It's -8 times 4, which is -32. Minus 11 times +4 is equal to -44, and then plus 3. So as a -76 plus 3 is equal to -73. All right, very good, Isabella. So now let's move on to unit 2. So who can tell me a little bit about unit 2? So unit 2 is solving equations, right? We solved equations in unit 2, right? So we solved linear equations in unit 2. That's what we did. And today we're going to review units 1 through 4. We had 8 units in total, so split cleanly in half. Today we'll just review unit 4. Next lesson we'll review 5 and 8. So tell me a bit about linear equations. What do you use to solve them, right? You use inverse operations, right? So let me list these these operations. So when you solve these linear equations, what you need to do is you need to use inverse operations to reverse operations and then isolate the variable on one side and the numerals on the other side. So who can tell me what is the what is the inverse operation of addition? What is the inverse operation of addition? It's very easy. So just real quick, rapid fire. What is the inverse operation of addition? So just put in the chat the inverse operation of addition, which is just going to be the opposite, which is going to be subtraction. So now tell me, what is the inverse operation of multiplication? Just division, right? And for example, if you have like x squared, that's going to be square root, right? So it's very easy. So now let's just try to solve this problem. And let me give you a hint. First of all, you want to multiply everything by 12 to get rid of the denominators, right? So, okay. So I'll just give you a moment to solve these problems, right? To multiply everything by 12 first, that's your hint. And you can solve it pretty easily after that. All right. So, let's see here. How about Isabella? Isabella, could you help us solve this problem? If you don't know, that's okay. I'll walk you through it. So, can you unmute and help us with this problem, Isabella? Or you can type in the chat if you want.
I'm not really sure about this one.
All right, that's fine. Just answer these small questions. All right, so the hint about this one is to, what? To multiply everything by 12, right? So what is x multiplied by 12?
12x.
Nice. Okay, what about this thing multiplied by 12? See, it's quite simple. So if you multiply this thing this big thing by 12, you can see 12 and 4 kind of cancel out. So you're left with 3 on top and 1 on the bottom. So it's only going to just be 3 times 1 minus 3x over 2. So similarly, then 12 times this is just going to be 4 times 2 minus x over 4, right? All right, and finally, Isabella, what is 11 over 12 times 12?
11.
Nice. Okay, so now we're done, right? But we're not done yet, because we need to multiply everything by 4 now, because we still have this denominator. It's annoying to deal with, right? Because we don't want that. It's hard to solve with that. So let's just multiply everything out real quick. So 12x. All right, Isabella, help me distribute this. How would you do this? So what is negative 3 times 1?
Negative 3.
And then what is negative 3 times negative 3x over 2? It's going to be plus.
Um,
And multiply the top first. It's 9, right? 9x over 2. And what about distribute this?
8 minus x.
Nice. Okay. And then finally, it's just minus 11. So as you can see, we still have this 2, and we don't want this. First, let's just combine like terms. Let's just combine like terms real quick. So the point of doing inverse operations is to isolate the variable, right? So let's just move the variable on one side and the numbers on the other side. So first we need to move this x to the other side. So that's going to be equal to 13x to move it to the other side. And then this negative 3 needs to move to the other side as well. So then it's going to be plus 9x over 2 is equal to 8 minus 11 plus 3. As you can see here, it's just equal to 0 because everything cancels out. This is equal to 0, and then because no matter how much x is equal to here, if it all equals 0, then x is equal to 0. You can plug it in. If you plug it into this equation, you'll see that it is true. So if you plug it in, 0 minus 1/4 is equal to what? 2/3 minus 11 over 12. Can 8 over 12 minus 11 over 12, which is negative 3/12, which is negative 1/4. So it is true. And that is why x is equal to 0. All right, Isabella, do you know how to do it now?
Yeah.
Okay, good. So now let's move on to another unit 2 problem. So let's just, we can't really run out of time. So I guess I'll just walk through this one real quick. So how about Kaylee this time? Would you like to help?
Okay.
So this one, I didn't really give you time to think, but if you look at it, it's actually pretty obvious. So how would you do this problem?
I'd add all the sides together and then divide by 2.
Very good, very quick. So as you can see here, a plus b plus b plus c plus a plus c. As you can see here, a plus b is 44, b plus c is 45, a plus b is going to be equal to 29, right? So let's just add those together. Equal to what? 118. And as you can see here, we can actually just combine all of these like terms. It's 2 times a plus b plus c, and we don't actually need to find what a is because it just asks for the value of a plus b plus c. So since we know what 2 times that value is, we just divide it by 2, and a plus b plus c must be equal to what, 59. Yes, is that correct, Kaylee?
Yeah.
All right, very good. So now let's move on to Unit 3. This is about the inequalities and inequalities. So let's do these inequalities. I'll give you a couple moments to try and do this. So remember, let's review a little bit on inequalities before we try to do anything. So how would you solve inequality? Use inverse operations again. All right, you're still using inverse operations. You're still using inverse operations. What is the catch, though? What is the catch? The catch is that you flip the sign. You flip the sign when multiplying slash dividing by 0, or not 0, dividing by a negative. So the only catch is that you flip the sign when you're multiplying or dividing by a negative number. You're just going to flip it. So what do I mean by flipping it? Well, if your sign is like this, which is less than, what you're gonna do is you're just gonna flip it the other way. If it's like this, you flip it like that. If it's like this, you flip it like that. All right, just flip it the other way. And that's flipping the sign. It's only catch rule, really. All right. And this is just a compound inequality. And one thing that is nice about compound inequalities, since it's two inequalities just mushed together. And the thing is, you can actually solve them simultaneously. Since this is just going to be equal to x plus 2 over 6 minus 1 is less than or equal to negative 3. And x plus 2 over 6 minus 1 is greater than negative 5. You're still going to use the same inverse operations to solve them, so you can just solve them at the same time. That's a compound inequality. And in the next slide, we'll talk about the absolute value inequalities. Make sure you don't forget those because those are pretty important later on. All right. I'll give you a couple moments to solve this problem in your notebooks, and then we'll talk about it. All right, so I've given you some time to solve this. So now let's start solving this. Okay, so we have a chat message. Isabella says x is in between -19 and -13. Very good. Let's see if it's correct. So what you can do is you can actually solve these simultaneously, as I said before. So let's just add 1 to both sides, just like so. Both sides, you can just solve both sides at once. So this is going to be -2. This is going to be -4. And now you can also multiply both sides by 6, right? It's going to be -24 is less than x plus 2 is less than or equal to -12. And then finally, you see it's going to be -26 is less than x is less than or equal to -14. So Isabella, your answer is incorrect. Do you know where you went wrong? Do you understand now? Do you understand how where your mistake was? Okay. So now using interval notation, right? Remember interval notation, right? It's going to be equal to -26 to -14, and it's in this interval. That means it's in between -26 and -14, and this is going to be a square bracket because it's including -14. If you want to graph it, it's very similar. You can just tell by the interval notation, since it's in between -26 and -14. That's exactly how we're going to graph it. It's -14. It's just going to be in between. But there's a difference that -26 is an open circle, meaning it's not included, and -14 is going to be a closed circle, meaning it is included in this interval. And that's how you're going to graph it. So how about this absolute value inequality? So one more thing to remember about absolute value inequalities is that you can turn them into compound inequalities. So when the absolute value of x is less than a, x is going to be in between a and -a. All right. When the absolute value of x is greater than a, x is going to be equal to is either greater than a or it's x is less than -a. And in this case, since it's greater, you're going to be using this bit of information. So make sure that's my hint to you. Okay, now you can solve it. I'm giving you a couple moments to solve that. All right, so let's do this. And everybody is saying in between -15 and 15. All right. Okay. So let's talk about this. First of all, it's probably not going to be in between -15 and 15 because I know where you're getting it from. Because after you move 1 and multiply by 6, it's going to be absolute value of 4x is going to be greater than what is this 60. But as you can see in our bit of information here, if absolute value of something is greater than your number, it's not going to be in between. It's going to be x is greater than a or x is less than -a. So instead, what you're having here is 4x is greater than 60 or 4x is less than -60. And in that case, x is greater than 15 or x is less than -15. So it is not in between. And the interval notation will be like this. It's going to be equal to -infinity to -15 union 15 to infinity. And this union is just shows that it's either less than -15 or greater than 15 here. So that is the interval notation for that. So do you know where I'm getting this, right? It's not going to be in between. It's going to be outside of it. And if you illustrate this, it's going to be an open circle. This is 15. This is -15, for example. It's going to be outside. It's going to be out, going out. See, if it was in between, it'd be here, but it's not. So it's going to be going branching outwards. So finally, let's go on to unit 4. So unit 4 was all about linear graphs, how you graphed lines. And let me just go back and tell you about the slope-intercept form. So y is equal to mx plus b. This is a slope-intercept form where m is the slope and b is the y-intercept, right? And we'll go more about that slope-intercept form later. And also we have the point slope form, in which case it's going to be y minus y1 is equal to m times x minus x1. So let me just show you how we do this. And of course, m is the slope. So what is slope? Slope is change in y over change in x, which you probably heard a lot of times before at your school or anything. The teachers tell you it's the rise over run. That just means that it's delta y over delta x. What does delta mean? Delta is the change in y over the change in x, which means the slope here is just going to be the difference of the y values and the difference of the x values. So it's quite simple. So let's say like it's -1 minus 4 and 3 minus 2. Therefore, we get the slope is just going to be -5. That's just the slope. Now we can't really use the slope-intercept form here. We can't use that because we don't know what the y-intercept is. So we can't actually use that. So instead what we could use is we could find the equation using the point slope form. And the point slope form is the best. It's the best equation and it's the standard equation because all you need to get a point slope equation is just 2 points. You just need to find the slope and let's say, and you just pick one of them. The y1 in this case is going to be here. And the x1 is going to be here or whatever point you pick. And y and x are just the general variables. So if you plug that into our equation, y minus -1 is equal to m times x minus 3. And we know that m is just going to be -5. And that's our point slope form. It's very easy. It's going to be y plus 1 is equal to negative 5x plus 15. And then you just move the 1 to this side. It's going to be equal to y is equal to negative 5x minus plus 14. So why did we move the 1 to the other side? That's because we want to change it to slope-intercept form. By moving the 1 to this other side, then we just turn it into slope-intercept form, and now we can graph. So now we can graph using the slope-intercept form, or you could just use these 2 points. Just connect those 2 points, and that's a line. Same thing. So let me just regraph this for a second. Here, put this over there. And it's going to be equal to y is equal to negative 5x plus 14. That is our equation derived from point slope form and then converted to slope intercept form. So the easy way to do this, which might not be so easy when you get bigger points, is to just connect the dots. It's 2, 4, right? So 2, 4 is here, and then 3, negative 1. 3, negative 1 is here. Connecting the dots, we get this line right here. Or you could do it the y-intercept way. So can anybody tell me what is the y-intercept in this equation? What is the y-intercept? All right, what is the y-intercept in this equation? So where is the y-intercept? How about Kaylee? All right, Kaylee, unmute yourself and tell me what is the y-intercept in this thing? Okay, what is it?
0, 14.
It's 14. Very good. 0, 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. That is our slope-intercept form. So what is the slope in this case?
Negative 5 over 1.
All right, so negative 5 over 1. And since the slope is change in y over change in x, first we're going to change in y, right? And that's just going to be equal to, basically this is over 1. So it's going to be minus 5, then over 1. So change in y is going to be negative 5. So let's move down 5 units. 1, 2, 3, 4, 5, which is here. Then we got to move to the right by 1, which is the change in x. Wait a second. Did I do this correctly? No, this is not correct. Because this is not correct. Sorry about that. This is negative 1, and the point is gonna be here because it's a negative slope. All right, I had a small mistake. Now the graphs are identical because if now you connect the dots, it's gonna be the same graph. Now in this case, obviously the first method is better because you don't have to draw all this big y-intercept. It's 14, a lot of lines, right? But when you get bigger points, it's hard to connect the dots like that. So then you must use this second method, right? So you can use either method that you choose, right? Okay, now let's move on to our last one. It's pretty easy, right? Just convert it into slope intercept form, which is y is equal to mx plus b, and then you can just graph. I'm just gonna give you a couple moments to do that, and I'll go over it. All right, so let's try this one. So let's see here. So all we need to do right now is just going to distribute and simplify. So let's just evaluate this, right? Then we can combine like terms and then do all that stuff later. So 3x minus 2x minus 2y, that is the side, and we can actually combine the x later, equal to 5 minus y. You get x minus 2y is equal to 5 minus y. So how about let's move this y to that side and 5 this side. So then we get x minus 5 is equal to y. And that's it. That's our slope-intercept form. Now we can just graph. So graphing is pretty trivial, very trivial, because we know the slope is just going to be equal to 1. The y-intercept is just going to be equal to -5 here. So we're going to go up 1 and to the right 1. It's going to be here. And that is just going to be your line here. So I hope everybody understood that, right? Not too difficult, just a small review. So now that's it for today. I'm pretty sure. Okay. I'll see you all next week. All right. Thank you for coming, and see you all next week. And I'll post the homework shortly.